The electrical transmission grid is vital as it powers our entire society, but open, up-to-date and accessible data of our grids is lacking. So what if I told you that you could easily map your own country's grid on OpenStreetMap and have an impact on decarbonizing our energy systems and achieving full electrification? In this video, we will go through different tools and strategies that you can use to find new unmapped power infrastructure, but also increase the quality of the existing OpenStreetMap grid data. So let's get started. The first thing that you want to do is go to our website and then go into our tools and strategies. Here you have all the tools and strategies that we've developed and that we'll be going through in today's video. So the first tool is Osmose, which is basically a quality assurance tool that detects issues in OpenStreetMap data on a daily basis. It's one of the main tools that we use to fix and find power infrastructure in OpenStreetMap. And so, for example, finding unfinished transmission lines is an issue that it can detect. So how do we use Osmose? So there are two ways to use Osmose. Is one using the official Osmose website and their GUI. So you can go to the website and essentially look for the different issues here. But another way to use it is basically using our Map It page. So if you go to our Map It page, here in the tools and hints, you will see Osmose issues. In terms of usability, the difference between using the actual website and our tool is basically that our tool at the moment has a limit of 5,000 issues. So for very big countries, it might be better to use the actual website, especially if you're trying to focus in a specific region. So I'm going to show you how to use it. So basically here you've got different issue types that we've put in our interactive world map. And for beginners, we recommend this one, which is unfinished power transmission line, but you've got many different other classes, which can help you fix specific issues. So once you have this button selected, you can essentially go to the country that you're interested in. So I'm just going to pick, for example, Burkina Faso. And then when you click on it, it will basically download a GeoJSON. So you're going to download that. And so then you're going to go to JOSM and you're going to open the GeoJSON in JOSM. So you can just go to your Explorer and essentially drag and drop. All these little triangles are Osmose issues for Burkina Faso. Now, what you ideally want to do is to have the country loaded. So what you could do is just go back to our Map It page and essentially load all of the OpenStreetMap data for that country. And so that's the loaded data. And so essentially, so if you activate the Osmose issues, so what you could technically do is go through every single one and look at what the issue is. But a much faster way to do this is to actually use the To-Do plugin. So essentially, if you go to Edit, Preferences, and then you go into Plugins, you want to type To-Do, and you want to tick on this to have it activated, and then OK. And then to use it, you just go to Windows, and then To-Do List, and at the bottom right here, you'll see the To-Do list. Now you've got nothing in that list. So to add all of these issues into that list, you just Control A, essentially to select all, and then you can do Add here. And as you can see, I've added all of these triangles, all these nodes into the to-do list. And then you can just go back to the layer with all of the data. And what you can do is zoom in to the different nodes, pass and mark. So zoom into the first node. And here you can see that this is an Osmose issue as it's unfinished. So this line is not finished, which is why it detected it. And so you can basically just go through the different nodes and see which ones you can fix. So for example, here is one of the Osmose issues, which is an unfinished transmission line. So here, for example, if you haven't seen our starter kit video tutorial, then I recommend seeing that. But basically, the way that you would essentially extend this line is clicking on here, drawing node, and finding the next one, which is here. And then you can essentially just extend it until you no longer can extend it. And so as you can see, I basically managed to find an unfinished transmission line thanks to the Osmose issues tool. So now the second strategy that you can use is just simply spotting the gaps in the grid thanks to our map CSS. So thanks to the visualization of the lines with the different colors. So essentially what you can do is go to our Map It page and essentially click on this and you can load the country that you're interested in. So in my case, I'm going to click on Vietnam. And once your country is loaded, you can essentially just go through the country and sort of spot just by looking at the grid what is missing and what is unfinished. So for example, here I can see that this line is clearly unfinished. So if I simply zoom in, for example, here, I can try and find the next tower, which is here, for example. And so essentially I can just extend this line until I can't extend it any longer. So just by spotting the gaps in the grid, you can essentially find plenty of stuff to map. So for example here, just clearly this isn't finished. So this imagery isn't the best. So if you change to Bing, for example, here I can see that there's another tower. So I could, for example, extend this and continue mapping like this. So just by essentially looking at the grid, you can basically see a bunch of different issues that you can easily fix. Third strategy that you can use is basically looking at substations and connecting them. So essentially, as most national transmission grids are connected, substation lines go between each other. So essentially, if you look through every substation, you might be able to find new unmapped power lines. So essentially, first you want to load the country that you're interested in. So for this example, I'm just going to go to Ghana, for example. Once your country is loaded, what you want to do is Control F. Now, if this doesn't work for you, that's because you need to be on expert mode. So have this essentially activated and then Control F. And essentially here, what you want to do is filter for only the substations. So what you can do here is simply go to our website and essentially copy paste this line. And that basically gets all the ways that have this power equals substation tag. And as you can see, it only selected the substation. And the way that you can quickly go through every substation is using, once again, the to-do plugin. So adding it to the to-do list. So once it's selected, you just add, and as you can see, I have all the substations at the bottom right here. Now I can basically go zoom in and pass and go through every single substation and see if I can find any new transmission lines.
12 seconds later.
So as you can see, I just went through a few substations in the to-do list and I found this substation which hasn't been connected to any lines. I can see a tower here. And so for example, I could map this line. So like this until the next tower. And so basically just by doing this, you can find quite a few new lines just by going through all the different substations and sort of looking around the substation if there are any new lines. So now the fourth tool and strategy that you can use is basically finding and connecting power plants. So in our Map It page, we've essentially integrated here in Tools and Hints, the Global Energy Monitor Power Plants database. So essentially when you click on here, when you have this activated and you click on a country, this is basically going to fetch all of the power plants that are in the Global Energy Monitor database and load them into JOSM. So for example, let's say you pick country, so Armenia. So you click on the country, and this is basically going to download once again a GeoJSON onto your computer, and then you can save it. And then what you want to do is basically just drag and drop. And here you can see all of the power plants that are in the Global Energy Monitor Power Plant database. Now, ideally, you want to have the country that you're interested in loaded. So you can essentially just load Armenia. So I have Armenia loaded. And now if you go back to this layer, these are all of the power plants. Now, what you could do is Control A, select all, and then add them to the to-do list, and then go through every single one. But sometimes it's actually better to just sort of look where you think they haven't been mapped. So clearly these ones have been mapped because I can see that the layer underneath, which has all of the data, clearly has, as you can see, the data already been mapped. But for example, this one, so the power plant here has been mapped, but it's clearly been isolated and it might be connected to the grid. And so here you can see a small substation for the power plant. And so here, for example, I can map this, making sure that the good layer is activated, so the one with all of the data. And basically, I could, for example, map this substation like this. And then I can see there are some poles here which go up like this. And if you map it, then you can probably find that it might lead to a substation and maybe the transmission grid. And so here I continue the line a little bit, and I actually ran into an unmapped substation, which also has many unmapped towers and thus transmission lines, which all the way here I could map. So let's try and find an example where the power station hasn't been mapped at all, but is in the GEM database. So I'm still on Armenia, and here I have a power plant, which is supposed to be a solar power plant, which hasn't been mapped. Now, I think that this is probably going to be the power plant. Unfortunately, with Bing and Esri, you can't see it. But actually, what you can do in certain cases is use the Sentinel-2 data. So if it's not activated, you can go to Edit, Preferences, and then go into Imagery, and then go to Sentinel. And you have different dates, 2024, 2023. And essentially you would press on the one that you want and activate it and then OK. And so here, for example, I've got the 2024 version. And so if I activate this one, I can actually see, not very well, but that these are definitely solar panels. Another thing that you can actually do is go onto the Sentinel Copernicus browser. So essentially this website, and you can essentially copy the coordinates of this point. So a quick way to do that is Control-Shift-C. That copies the coordinates of that point. And then you can add them here to the top right, which I've already done. And here it's not very good quality, but you can clearly see that these are solar panels. So technically I could be able to map this power plant, but since the imagery isn't good, I have no way of knowing if there are any lines going through and out. Now, interestingly, I actually found here a small hydropower plant, and you can see here a substation, although it's not very clear, but this is clearly a substation, which is probably going to be connected to this power plant. So essentially, thanks to this tool, you can A, find power plants that are not mapped in OpenStreetMap, and B, you can also maybe find power plants that are not connected to the grid, and should be. So the fifth strategy is basically going through different industrial areas, as many big industrial areas are basically connected to the transmission grid. So how do you do this? Firstly, you can go to the Map It page and essentially go here and download all of the industrial areas in OpenStreetMap for your selected country. So for example, I'm going to pick Peru. And as you can see with these blue dots, it's loaded all of the industrial areas which are tagged with land use equals industrial. So what you could do now is go through all of them as we did before. So Control A and do the to-do list. But in many countries, there are a lot of land use equals industrial tagged areas. So if you only want to focus on very big industrial complexes, then you can go to our website and go onto this GitHub repository, which has a Python script, which you can essentially run with a command for any country that you want. And you can essentially add filters. So the country that you're interested in, and then the size of the area as well. And so if your country has many industrial areas, using this tool might be better. Let's see if I can find some unmapped power infrastructure just using this tool. So here I have an industrial area, but I don't know if it's connected or not to the grid. So what you could do is load that country's transmission grid. Or what you could also do is basically just download just that area into a new layer like this, and it's only downloaded that area. And so in this example, this is a cement industrial area, and I can see that this power line is not finished and it's not connected to any substations within the area. So here you can see the tower, or the pole in this case, and the next one is here and here. And as you can see, I found a substation here within this industrial area, which I could essentially just map and then basically just finish this line. And as you can see, I managed to finish an unconnected industrial area. Now, the next tool that you can use is basically the Wikidata tool. So basically in Wikipedia, there's a lot of power infrastructure that has articles, and they also have an attributed QID, so Wikipedia ID. And so we've made this into a tool which we've added to the Map It page. When you have it clicked, that you can essentially get all of these substations, power plants, or all power related infrastructure that has a QID. So that is basically in Wikidata, and load this into JOSM. So I'm going to choose just power plants, and I'm going to go to India, for example, and that's basically going to load the GeoJSON into OpenStreetMap. So basically you should get something like this for India. And so these are basically all of the power plants that have a Wikidata ID. Now you can basically, what we did before, Control A and add them all to the to-do list. And basically go through different power plants and see if they've been mapped in OpenStreetMap. But to be honest, a lot of the power infrastructure that is in Wikidata is already been mapped in OpenStreetMap, but not necessarily. I've actually found a power plant that is in Wikidata, but not in OpenStreetMap. And so basically, ideally you want to load this area. So I've already loaded the region, Tamil Nadu. And as you can see, this is the region. And so this power plant and here is the substation basically haven't been mapped. So here what I could do is just map the substation and the power plant. And as you can see here, there are two power towers which could link to a transmission line. So essentially, thanks to this Wikidata tool, I've managed to find this, and now I can map this substation, power plant, and also the lines going out from it. Now, let's say, for example, that you've mapped the powerhouse. One thing that's good practice to do is basically to add the QID as a Wikidata tag. So what you would do is basically do Wikidata, and then here you would put the QID. So for example, so here basically this is the country QID, so be careful, but the QID of this power plant, you can actually find it here, And you can essentially just copy that, go back to the other layer, and essentially add Wikidata, and then just add the QID. So this is a very good way to link Wikidata power infrastructure with OpenStreetMap power infrastructure. Now, another good strategy is basically using official data and maps from TSOs, for example, so transmission system operators, or any planning documents. Most of these will be in image form or PDF form, but some actually provide data in the form of CSV, shapefiles, etc. And so if you want to import this into JOSM, you essentially want to use the Open Data plugin. So you would go into Edit, Preferences, and then go to Plugins. And here you provide Open Data. And basically this allows you to import many different formats into JOSM. These, however, should be used as hint layers. So please don't import stuff that you shouldn't be importing. So the next strategy is to basically use Fixme tags. So basically many mappers add Fixme tags when they're unsure about the routing or potentially they can't continue a line. And so what they do is basically add a tag with Fixme. And so what you can do is just look for those and see if you can fix it, for example. So what you would do is go to the map it page and essentially load the transmission grid of that country. So in this case, I'm going to go with Venezuela, for example. So now once your country is loaded, what you want to do is Control F and then basically add Fixme equals asterisk, which is a wildcard. So basically any Fixme tags. And this is going to get you all of the lines or power infrastructure that have a Fixme tag. So here you got a few here with the red arrows. And so basically what you can do here is add them to your to-do list and go through different ones. So for example, if I zoom in here, this one has a Fixme tag, which says continue line. So here, for example, what I could do is continue the line. So basically by filtering Fixme tags, you can correct many issues and also finish unfinished transmission lines. The next strategy is basically to use OpenInfrastructureMap and particularly the nighttime layer. So what you want to do is go to OpenInfrastructureMap's website, which you have here, and then go into the layers and activate the nighttime light. Why? Because it's much easier to see the gaps in the grid. So if I, for example, zoom into Nicaragua, I can see that this line here is probably unfinished. So what you want to do is you want to zoom in until you see edit at the bottom right. And here you could basically edit with ID or JOSM. So let's click on JOSM. And as you can see, it loaded that area. So in this case, you can see the power tower and actually you can see the next ones here. So you could basically map this segment. But if you want to map the rest, then you could also load the entire country, which I've already done here, and just basically continue this line like this. So the following tool that we're going to be using is called the JOSM PowerNetworkTools plugin, which was basically developed by Russ from OpenInfrastructureMap. So there is a GitHub repository that explains how the tool works and how to use it, but I'm just going to show you here too. So this tool basically estimates the voltage of a substation bus bar from aerial imagery by estimating the face-to-face clearance, or basically the clearance between conductors. So first what you want to do is go to Edit Preferences, and then go to the plugins and look for PowerNetworkTools and have this activated. And so once you have that activated, how you can use it is go to Windows and then Voltage Estimator, and then you'll see it at the bottom right here. So this tool is a great way to assist mappers to estimate the voltage of substations. So let me show you how to use it. So basically here I have a substation with 225 kV coming in this way and 90 kV coming in this way. So let's say you don't know the voltage or you're trying to see if this is correct. If the imagery is good in this case, for example, what you can do is activate the tool. So either press V or on here on the left, you can do this. And here basically what you want to do in these bus bars is basically look at the distance between the conductors. So in this case, for example, you can see the phases spaced horizontally on the bus bar. And what you want to do by basically clicking on the phases like this, and basically at the bottom right here, you're going to get the measured distance, the face-to-face clearance, and the estimated voltage. Now, if we activate the data layer, we can see that this is 90 kV, and I got 112 kV. Now, this makes sense because basically this is going to always be the upper threshold. So in this case, for example, if this line was a 400 kV line, and here you get 112 kV, then it's clearly an issue. This basically gives you the maximum voltage. Sometimes you might have a substation which is built for example, 400 kV, but only utilizes 225 kV, potentially for future work. works. So think of this as the upper threshold. So if we go to the other side where it's 225 kV, so basically looking at the distance between bus bars, so you basically do like this, and as you can see 285 kV, so here 225 kV, which more or less makes sense. Now this is a great way to assist you, especially if you know the different voltages of that specific country. So here's another example, 225 kV. So what you can do is essentially look at the distance like this. 289 more or less makes sense. You can also look at the distance between the conductors here, basically the same. And as you can see, 225. What about the 90 kV? So in this case, it's a bit harder to see, but 100 kV, which basically makes sense. So here's another example in Nicaragua, and here it's not as clear, but you can still sort of do like this between the phases. 267, 230 kV here makes sense. So a few things, this is just a validation tool. Then this is going to give you the maximum range, so be careful. And there's also some error in the tool, but please go through the GitHub repository to learn more about this tool and only really use it if you're somewhat experienced. Now the next tool that we're going to be using is basically using street level imagery, and in this case Mapillary. So Mapillary is an open data alternative to Google Street View. What you can do is basically use this to find sort of towers which are maybe hard to see using aerial imagery, but also to validate certain things. So you can actually use this directly into JOSM. So in JOSM, what you want to do is basically go to Edit, Preferences, and then go to Plugins, and basically download the Mapillary plugin. So as you can see with the green tick. And then you want to go to imagery, and here you'll have the Mapillary imagery. Now I'm going to show you an example where it might be useful. So I've loaded Togo, and basically, let's say I'm in here. Let's just say that you're unsure about the voltage or potentially just the existence of this power lines. Now you can actually use Mapillary to help you with this. So first you want to do is basically activate Mapillary. And to make it work, you need to be zoomed in. All the green lines are basically things that are in Mapillary. And so here, for example, I want to see this tower in an image. So for example, if I click here, then here I get an image 2023 with a date, and I can see that the transmission tower actually exists. And you can basically zoom in like this, sort of move around, right clicking. And here is one of the towers that connects to the tower behind it, which is probably this one. And as you can see in the distance, there is also a tower here, which is this parallel line, which does make sense. And actually here you can see some poles which haven't been mapped. And if you can see them using different imagery, you could actually probably map this power line, which is a lower voltage. But as you can see here, this tower here. And so basically using this imagery like this can help you find new power infrastructure, but also validate it. And I think especially help you with the routing. Sometimes you're not really sure which tower connects to which one, especially near substations. If that substation is, for example, near a road. So it's like that Mapillary might have some images that could help you. You could also use Mapillary's website instead of the plugins. So if I want to see the images on Mapillary for this case, I can essentially click on the tower, Control-Shift-C to essentially copy the coordinates. This is a small hack. And then go into Mapillary and then Control-V, and I can jump here. And I can basically see the same imagery. As you can see, if we go back a little bit, that's one of the towers, that's the second one there. And this is that pole that we were talking about that you could potentially map. Now the next strategy is more of a way to, let's say, map interconnectors in a faster way. So basically, a lot of times you might be mapping a certain country and you will only have that country loaded. So for example, here I have Tunisia, and I can see that this line here is an interconnector that's going into Algeria, but I'm unsure if it's been mapped or not, because sometimes you might be tempted to basically just extend the line like this. But the thing is, you haven't loaded that country. So the fastest way to check that is just by actually going either into the imagery in OpenStreetMap, or you can go into here, download, and actually go onto the Slippy map, and you can kind of see that indeed these lines have been mapped. Now, let's say that they weren't mapped, but let's say instead of using the Slippy map, you actually want to download just this region. We actually have a query which you basically want to copy here, so just press here, and then copy this, Control-C, and then go back into JOSM and go to download from Overpass API, and you essentially want to paste this here. Now, if you go here, this is the admin level. So admin level 4 is basically regions and 2 is countries. So if you're doing admin level 4 like I'm doing here, it's only going to load all of the power infrastructure for that specific region here in Algeria. So then what you want to do is select a small bounding box, and then download as new layer. And as you can see, it's loaded this region of Algeria, but I still have Tunisia here loaded, and this is that line. And so here basically I can have a much better time trying to map this side of the border instead of, for example, just downloading this small area like this. So this can save you quite a lot of time. Now the final tool that we're going to be using is basically a tool that we've built for Powerplantmatching. So basically Powerplantmatching is a Python repository that combines and harmonizes different power plant datasets like Global Energy Monitor or OpenStreetMap, and it's widely used for energy system modeling. So this tool here isn't to find unmapped power infrastructure, but more to improve on the current tags. Now, how do you use this? So basically go to the Map It page and go Powerplantmatching, and here basically when you click on a country, you're going to get all of the power plants that were rejected by Powerplantmatching and the reason why. So for example, what you would do is click on a country. So for example, I'm going to click on Romania, and then this is going to load the GeoJSON directly into JOSM. And as you can see, all of these are the power plants that are in OpenStreetMap but have been rejected by Powerplantmatching. So here I have one of them, and I can click on it, and basically on the right here I can see the country and sort of other information, but in this case the most useful one is looking at why it was rejected here, because there's a missing source tag. So if we just basically download this power plant like this, then we can see that this is the power plant that it was taking. Now if we go into the tags, we can see that indeed it's been tagged as a power plant, but not with the source. So what you can do is maybe click on the preset, and then here you've got all of the different plant sources, and I know this is hydro, and then you can apply this preset. And so now Powerplantmatching wouldn't reject it because of this reason, but actually it would reject it still because many hydropower plants are missing the method. So essentially when you go into the preset of hydropower plant, at the bottom you got the method, and in this case it's either run of the river or water storage. So here I have another example, this time in Spain, and this section of the solar farm has been rejected. Now why is that? So the capacity placeholder value is missing and the name. So in this case it might be a bit harder, but actually what you could do is do some research online, and you might be able to find the capacity and the name of the power plant online and use it if the source is viable. And in this case I did a little bit of research, and I can actually find the name here and the capacity, and if the source is viable, such as the official operator, then you can actually use this. That's it for this tutorial video on tools and strategies to map power infrastructure in OpenStreetMap. I hope you liked this video, and for those who use the ID editor, stay tuned for a video specific to ID on how to map power infrastructure.